In this lesson, we're going to look at more properties with logs. So we have three different properties that we're going to take a look at: the product property, quotient property, and power property. So basically, whenever you have log of the same base is when you can apply these properties. So for this product property, if I have log with the same base and I'm adding log of x plus log of y, that's equivalent to saying log of that same base of x times y. So the addition becomes multiplication. Now keep in mind though that it does have to be two separate logs added together equals the log of the product of those two things. You can't split this up as log base b of x times log base b of y equals log of x plus y. It doesn't work the opposite way. So it only works this way. So an example of that would be like if I have log base 2 of 5 plus log base 2 of 7 added together is equivalent to saying log base 2 of 5 times 7, which is 35. So keeping in mind that the logs have to have the same base in order for these rules to apply. So the quotient property is basically the opposite of this. If we have subtraction between the two logs, then it's equivalent to taking the log of the quotient of the two x and y. So an example of this, if I have log base 2 of 10 and I'm subtracting log base 2 of 5, this is equivalent to saying log base 2 of 10 divided by 5, which is 2. And then the power property is basically saying that whenever you are taking the log of something that's being raised to a power, it's the same thing as taking that power and basically making it the coefficient. So you take the power and you can bring it down in front and just multiply log base b of x times that a. It also goes the other way. So if I have a coefficient, that really means that it's the power of whatever you're taking log of. So you're gonna see that one a lot. So basically, if I have something like this, log base 2 of x squared, I can think of this as this 2 being the coefficient. So 2 times log base 2 of x, and vice versa. So I could start with 2 times log base 2 of x and know that this 2 can get bumped up to an exponent. So seeing how these properties apply, we have two different types of problems that you would have to be able to do. One is condensing log expressions, and the other one is expanding them. So if you look at these are longer. So basically what we're trying to do is we're trying to use these properties to condense this and to get this smaller. So order of operations does apply here. So remember, order of operations is PEMDAS. So we're going to start from the left here, and we're going to kind of look, do we have any parentheses? No. Exponents would be our first thing that we can take care of. So anything that's a coefficient is going to get bumped up to an exponent. So what I mean by that is this is really going to be log base 3x squared plus log base 3y minus log base 3z to the third. So I took care of the exponents. Now I'm going to take care of multiplication or division. So in this case, we have this addition is actually going to turn to a multiplication. This subtraction will turn to a division problem. So because they're in the same level, we start left to right and just kind of group things in that order. So the first thing I'm going to do is I'm going to combine these because they have the same base. So what I can do is make this log base 3 of x squared times y. And then I can just carry along this. So now what happens is now I have subtraction between these. So this ends up becoming log base 3 of this whole thing divided by this. And then that would be the most condensed that I can go with this. So that would be my answer. Keep in mind that because you, after you're in your order of operations, you start moving left to right. So that creates this where these actually get multiplied. And then when I divide by this z to the third using the subtraction rule, I have this step. So I'm taking this and dividing it by z to the third. So it's the whole thing divided by z to the third. So the order here does matter because if you combine these first, then those would, it would be y over z to the third, and then you would be multiplying by x squared, which in this case would end up giving the same answer, but it won't always, so you just have to be careful. So looking at number 2, we want to do the same thing. We want to condense this. So first thing I'm going to do is look for those exponents. Let's move those over. So because these are all ln's, these all have the same base, because remember, ln is just the natural log, so log base e. So this first one, it's going to be 4 to the third minus ln of 8 plus ln of 2. So now I can divide these. So this is ln 4 to the third. I'm just going to rewrite it is 64. So I'm just going to rewrite that. So I divided these plus ln. And now I'm going to multiply these. So let me just simplify this. 64 divided by 8 is 8 plus ln of 2. So now what I do is, since it's addition, I multiply these. So 8 times 2 gives me 16. So this reduces to ln of 16. So this would be like the exact answer when you reduce this. The next example. So for this one, again, exponents first. So we have log, there's no base. So remember, it's assumed to be base 10. So they all have base 10, and you can only do these rules if you have the same bases. So the rest of the stuff just stays. Since I have addition and subtraction are in the same order, or it's converting to multiplication and division, which are in the same order or in the same levels, we're going to move left to right. So left means I'm going to combine these first. So that's going to be division. And now we're going to do multiplication between these. So we have x to the 5 times z all over y. Because when you multiply this, this is like, so if I have x to the 5th over y times z, this is like z over 1. So you multiply across the top, multiply across the bottom, you get y. So that's where I got that from. So there's the answer for that one. Number 4. For this one, now we have parentheses. So thinking about PEMDAS again, order of operations, you have parentheses, so you need to do that first. So I'm going to keep my exponent. There's addition here, so that means it's going to be log and multiply those. Now I can do my exponent. I did the exponent before. It wouldn't really make a huge difference in this case. But again, I'm really just trying to follow the order of operations so that we're consistent in case it does make a difference. So then now we have subtraction. So that means division. And that's it. So if you compare number 3 and number 4, so these two, those parentheses made a huge difference because we didn't get the same answer. So that's why it's so important to keep your PEMDAS rules or order of operations rules when you're doing this, because those make a huge difference. Sometimes it won't matter, but other times it will. So just remember, follow the order, and if they're at the same level, like multiplying and dividing or addition or subtraction, you just do them left to right. So then the next set of problems that we want to look at is expanding. So basically, if you look, these have been condensed, and now I'm going to expand it. So for this one, you don't necessarily follow order of operations. You kind of look as going backwards. So what was the last step that happened? So since I have this division, that division tells me that I actually have log base 5 of this entire thing minus log base 5 of z squared. So then that division kind of comes out to this. So you kind of start breaking it apart little by little. Now I look at this right here, and I want to break this apart because I know that this could end up being log base 5 x to the 4th plus log base 5 y to the 3rd minus log base 5z squared. So basically, if you look, if you imagine doing this, addition and subtraction, if I combine these, I would combine these first because it's on the left to get this, and then I would be left with minus log base 5z squared. And then the last step going backwards here would be to divide these. So basically you're doing order of operations backwards because you're like undoing this. So then from here, the only other thing I can do is I can take each of these exponents and bring them down. So I end up with 4 log base 5 of x plus 3 log base 5 of y minus 2 log base 5 of z. And again, if you wanted to check this, you basically start with the expanded version and go backwards. And I kind of did that as I was doing the whole process. Each step I'm looking. So basically, just kind of keep that in mind. You can always go back and check. So next thing here is to look at dividing this. So we have ln. So since it's been divided, that means we have subtraction minus ln 5c to the 5th. And then next step here is let's look at breaking up these individual pieces. So since this is multiplication, this is ln a squared plus ln b to the 3rd minus, now this one here, we can break up as 5 times, like ln of 5 times ln of 5, or ln of c to the 5th, or you could just think of this as a constant. So I'm just going to still separate it here. And I need to put this in brackets because it came from one piece. It's minus this entire thing. So I need to make sure that when I separate it, it's still going to be minus this entire piece. And then from here, we just take care of our exponents. So this is 2, bring the 2 out in front, bring the 3 out in front, and then just keep ln 5 as is, and then keep the 5, or bring the 5 out in front, and then keep this all in brackets. So then the last one here, again, let's separate it. So log base 8, the first way to separate it is by subtraction because it's divided. So notice that all of my logs have the same base throughout. So now what I'm going to do is I'm going to break this up into addition between these. And now this one, remember, because I'm breaking it up, I need to remember to do parentheses around the entire thing. And now we can bring the exponents out up front. And then this one, again, keeping that in brackets. And that's really about it. Keep in mind too, when I did this, these ones I put in parentheses. I could put these in parentheses. You don't really need the parentheses. It's up to you if you want to, but you do absolutely need the parentheses around this piece because you need to make sure that you're actually subtracting off this whole entire thing.